NVIDIA built a new CPU. Then they used that CPU to design their next chip. That is a closed loop that feels like it should not exist.
It does sound like a paradox, but the numbers are real. Early testing on production workloads shows up to 1.5 times faster performance on the most painful part of chip design.
Hold on, huh?
I always thought chip design was engineers drawing blueprints, not chips designing other chips.
That is what most people assume. Here's the thing. Designing a modern chip takes years. Not because the engineers are slow, but because before a chip ever touches a factory, they run billions of test cases. Every possible failure mode, every weird edge case.
So it is like writing software, except you cannot push a hotfix after shipping.
Exactly. One bug in a chip can cost tens of millions in wasted silicon. So verification is everything. And here is the bottleneck. Those verification tools still rely heavily on CPU performance. Not GPU, not AI accelerator. Plain sequential CPU work.
But NVIDIA makes GPUs. Why not use their own GPUs for this?
Good question. The nature of verification is different. It is very branch-heavy. One test result determines the next test. It is sequential logic, not parallel math. CPUs are still the fastest at that kind of work. So if you want to speed up chip design, you need a faster CPU.
So NVIDIA looked at this problem and said, let us build a CPU specifically for this job.
That is Vera, 88 custom cores designed entirely in-house. They call the Core Olympus, and it is paired with a special memory system minus LPDDR5X that feeds each core much faster than traditional server memory while using half the power.
Okay,
So they built a fast engine.
but does it actually move the needle in real work?
They tested two of the most demanding tools in the industry. Cadence Jasper, used for formal verification, catching bugs early in the design cycle, and Synopsys VCS, used for functional simulation, validating the entire chip behavior before fabrication.
Same software, same setups.
Same software, same number of cores, just running on Vera instead of a traditional server CPU. And both tools showed up to 50% higher performance on selective production class workflows. Not toy examples, real workloads that engineers run every day.
50% from just swapping the CPU.
That surprised people inside NVIDIA too. But think about what that means in practice. A verification run that used to take 3 weeks now finishes in 2. That extra week lets engineers test more design alternatives, catch more bugs, and move closer to a cleaner final product.
So Vera is not just a faster CPU. It is a time machine for the engineering team.
That is one way to put it. And the really interesting part is the loop. Vera is now deployed across the EDA workflows used to design future NVIDIA processors, which means the next generation of CPUs and GPUs, their design was accelerated by Vera.
So the tool that builds the next chip was built by the same company that designs the chip. That is a feedback loop.
Exactly. And they already announced the next step, a CPU called Rosa, built on an even newer core called Rigel. Each generation helps design the next one faster. The loop keeps spinning.
That is oddly beautiful. I mean, it is not quite a iDesign in itself, but it is close. The tool and the product are in a conversation across generation.
And the practical result is that every chip coming out of this loop is better than what would have been possible without it. Better GPUs for gaming, better AI accelerators, better data center chips. All of them carry a fingerprint from Vera.
So next time I buy a new graphics card, hidden inside that story is a chip that helped design itself.
That is the part that never makes the headlines. Everyone talks about the tool that shaped it.